طيب, we will continue today on the doing the PowerPoint for matrices. Already we knew what's a matrix, how we can do some operations in matrices like addition, subtraction, multiplication, and it's easy, yes. And we knew how to get the transpose of a matrix in our previous class. How we can get the transpose of any matrix? It is just by changing the row into columns and the columns into rows. So this is the transpose of the matrix. And we knew some rules in the previous class that the transpose, if we have a matrix and we got the transpose of it and then the transpose of this transpose, it will give me the first matrix. And we knew that I can add A plus B, the whole transpose, okay? So you can add first and then find the transpose of the matrix if you like. And this is the same as finding the transpose of the first and then find the transpose of the second. And then after that you add. So this result and this result, they are the same. So we can have it as a rule. And also A phi B, the whole transpose, this is equal to what you do for switching. So B transpose times A transpose, it's not in the same order. It's not A transpose phi B transpose. Okay, this is very important. Type R phi A and then the whole transpose. If we have a constant and we multiply it times the matrix, we know how to do that. So each element you will multiply and then after that we need the transpose. This is the same as what you can do first. You can find the transpose of this matrix first and then multiply R time it. So you're going to get the same result, correct? Because this is just a constant like 2, 3, half, quarter, and etc. Okay, so these are rules. Type. Now we will know something about the symmetric matrix. When we say that the matrix is symmetric, actually, we did it for some of you, but not all. Okay, in the previous class. طيب. What is the symmetric matrix? The symmetric matrix is the matrix that when you get it is transpose, you find that the new matrix, it is the same as the old matrix C. For instance, here, if we have C, it is this matrix. Now get the transpose of it. So what we do? We change the row to be column. So I'm going to get 1, minus 1, 3, and then 4. And then we go to the second one and changing it into column. So minus 1, 8, 5, and then 6, and etc. You can continue. Actually, it is this one here. Isn't it 1 minus 1, 3, 4, 1 minus 1, 3, 4, so minus 1, 8. Okay, so you reach here. Now, compare this matrix with this matrix. What do you find? You will find that this is 1, this is 1, this is minus 1, this is minus 1, 3, this is 3, and etc. Minus 2, this is minus 2. So you're getting what? You're getting the same matrix. So the C transpose is equal to C. If this happen, we say that this matrix is, it is symmetric matrix. Clear? يبقى لما نجيب transpose, when you find the transpose of the matrix, the new matrix is the same as the old one, so we say that the matrix is symmetric. And if he asks you to prove that this matrix is symmetric, just find its transpose. And if you reach to the same answer, then you are done. Type. Actually, when this will happen, which kind of matrices, when we find its transpose, we're going to find the same matrix, that they are the same type. They are the matrices that they have Aij is equal to Aji. يعني مثلا A13 is equal to A31. طيب, where is A13? This is A13. A31, it is this one. Then for another example, let's take A2, مثلا 2. This is the diagonal, leave it. A23 is equal to A32 مثلا. طيب A23, what is A32? So they are the same. Actually, as if you have a mirror here, there is a reflection through the diagonal. So the reflection of -1 here, this is -1, and there is a reflection here, correct? 5 with 5, and then 6 with 6, all through the diagonal. طبعا في الدياجونال A22 هتساوي شنو؟ هتساوي A22 صح؟ A33 يعني هي نفس العنصر. So this, okay, here where we put our mirror, or this is the diagonal. So the reflection is through the diagonal like that. So from the beginning, before I find the transpose of the matrix, I can guess that is it symmetric or not. Okay, clear? طيب, now we will have some rules now for the transpose. What are these rules? طيب, if we have any matrix, if we started with from any matrix and added to it its transpose, you will find that the new matrix is what? It is a symmetric matrix. Where is the 4 and 4? Yeah, this is 4 and this is 4. Okay, so this is A14 and this is A41, correct? So they are the same. All they are the same. Every Aij should equal to Aji. Clear? Okay. طيب. Now, let's take an example. He said what? If you start from any matrix A, if we add it to its transpose, then this matrix, the new matrix, is going to be what? It's going to be symmetric. Okay? So let's see that just by an example. First, this is A, and this is the transpose. Let's add them. What is the resultant? 3 plus 3, it is 6. 4 minus 2, it is 2. Minus 2 plus 4, it is 2. 5 plus 5, it is 10. This matrix, is it symmetric or no? Yeah, it is symmetric. This is the diagonal. So here 2 and here 2. And you can do it for any other matrix. And by the way, when we're talking about the symmetric, we are talking about what square matrices, not any matrix. Symmetric, we're talking about, you know, square matrices. Okay? Type a square matrix. So it is defined for the square matrix. Clear? Okay. So the first thing that if I started from any matrix, if I add it to its transpose, the new one is going to be what? It's going to be a symmetric one. Let's check if you want to check. So this is, let's call it C. Now, what is C transpose? C transpose is equal to, okay, the row will become a column. So 6, 2, and this row will become a column 2, 10. And it's clear from the beginning, as I told you. But to prove, just find the C and C transpose and then compare. Okay. Now, we want to prove that the new matrix A plus A transpose is also, it is a symmetric matrix. Type. What do we want to prove? We want to prove that A plus A transpose, this matrix, this is a matrix, it is here. When we get its transpose, we should end up by what? The same matrix. اللي هي شنو? A plus A transpose. Clear? Okay. طيب. Let's prove it. Okay, let me prove it. طيب. A plus A transpose. This is our original matrix. Now I want to find its transpose. So we had this theorem just here. that what A plus B, the transpose, I can, distribute the transpose here and here, the powers, correct? Like, so it's the same as A transpose for B transpose, so I can use it here. Okay, so this one is equal to, just you do like that, is equal to what? Is equal to A transpose plus A transpose, the whole transpose. But what we had before, we knew that the transpose of the transpose, it will give me back the matrix. Okay, yes. So this is equal to A transpose plus A. So am I back? Is this one the same as this one? Yeah, almost, but the arrangement is not the same. So we knew that if I have any two matrix, when I add A to a matrix B, is the same as adding B to A, correct? So it is commute. Addition of matrices is commute. So I can use it to do here. This is equal to A plus A transpose. Okay, now I change again. This was my matrix. This was my matrix. And I find to it the transpose. I end up by what? By the same matrix. So yes, يبقى A plus A transpose, it is a symmetric matrix. يبقى هي شنو? Symmetric matrix. How we prove? Find its transpose. Then you should end up by the same matrix as here. So is it clear? Is it clear? Type. Not that only. Yes. Not that only, but also if we started from a matrix A and we multiplied times its transpose, طبعا احنا قلنا it is a square matrix, okay? طيب, we started with A and we multiplied times its transpose. So this new matrix is going to be what? Also, it will be symmetric. That means what? That means the transpose of this matrix should equal to the matrix itself. So should equal to A في A transpose. Clear? And if you want to see this by an example, go just and multiply this one times this one. They are the transpose of each other, correct? So when you multiply it, check the new matrix. You're going to find that it is a symmetric matrix. Clear? طيب, let's prove it. Okay, we want to prove that this matrix is a symmetric matrix. How we prove it? طيب, we start from the matrix and find to it a transpose حقها. So we have A في A transpose. Now we want to change to check that it is symmetric ولا لا, يبقى حنجيب الترانسبوز حقها. Okay, طيب, do we have rule? Any rule for the multiplication? Yes. Which rule we had before? We had before that A في B. The transpose of that is equal to what? We flip, don't forget. So B transpose في A transpose, correct? So we can use this one here because this is the first matrix and this is the second matrix. And then this is the transpose. So this is equal to what? This is equal to A transpose, the whole transpose, correct? Times what? Times A transpose. So I flipped. Okay. طيب, and now what this equal to? What is this one? The transpose of the matrix. It will give me the matrix times A transpose. Type, did I reach or not yet? We compare this one and this one. Do we need extra work? No, already I am there. So I found that the transpose of this matrix, it is the same as the matrix. So I'm done. So that means it is a symmetric matrix. Clear? Now, moreover, if we have هنا كانت any square matrix, correct? And then for any square matrix, if I multiply times the transpose حقها, the new matrix is what? It is symmetric. And A plus the A transpose also it is symmetric. Now, when we start, take A and B, both are what? Are symmetric from the beginning. They are what? Symmetric. Now, he said, the matrix A, which is symmetric, times the matrix B that is symmetric plus B في A is also symmetric. يعني دي the new one should also be symmetric. A is symmetric and B is symmetric. You can do examples. Take any two matrices that are symmetric. طبعا should be of the same size عشان you can multiply them لأنه الماتريسز حقتك square. فيا إما يكونوا 2 by 2 يا 3 by 3 يا okay. But you have to know how to prove. طبعا يا جماعة بالأرقام سهل جدا. بس you have to understand how to prove. Okay. يعني مثلا this is A. الvalues حقتها شنو؟ احنا لازم يكونوا symmetric. I'm sorry. لازم تكون الماتريكس symmetric. طيب one of the symmetric matrices مثلا اهي this one اللي هي 6 2 correct و2 و10. طيب so this is the first one. Let's call it A. Give me any B symmetric. What do you think? المفروض اكون مهتمية بشنو؟ This is the diagonal, but what I put here I should put here. لو عايزة أجيب أي matrix that is symmetric. طيب for instance if I put here 3 I should put here as well 3. صح؟ عشان ما تكون إحنا ما قلنا شنو AIJ should equal to AJI. Correct? So A12 should equal to A21. Yeah? يبقى if this is 3 then this should be 3. Here what should I put? Any numbers. Even لو كان 1 و 2 ما في مشكلة. لأنه this is A11 ودي A22. So the numbers of the diagonal ما في مشكلة. No problem. You can take them any two numbers. So if you check, this one is symmetric and this one is symmetric. Yeah. Now multiply A في B and multiply B في A and then add them up. You should find that this resultant one, this is a homework, okay, for you since you like to work with numbers. Type. So this one, you will find that it is a symmetric one. يعني معناه مفروض ألقى شنو؟ You should find the resultant if you look at the diagonal like that. So this number and this number are going to be the same. Okay? And go and do it as a homework. If we have A from the beginning, can I take this one? No. Why? Because it's not symmetric. I got a symmetric one after I added this to its transpose. So I get this one. Okay, so I took it. So A should be a symmetric one and B a symmetric one. So after that, AB plus BA, it should be what? It should be symmetric. It's from your side. صوت موجود صح؟ نبهوا from its side. Okay. طيب. يبقى let's prove that. Let's prove that this as well, it is a symmetric one. What we'll do? So we get the transpose of this and we check, are we getting the same matrix or no? If we're getting the same matrix, then we're done. Type. We had a rule. What's that rule? Which rule? That if we have addition of two matrices, so the transpose of them, we can what? Find the transpose of this part first, and then this one. And then after that, at the end, we add. if he asks us to prove. If he asks us to prove, then we have to. طيب. Okay, so لو وزعنا transpose هيبقى عندنا AB the whole transpose زائد B في A the whole transpose. I used the previous rule. صح يا جماعة؟ احنا ما ننسى القوانين. Which rule? This one. If the addition of a transpose of the addition of two matrices is the same as the transpose of the first matrix plus the transpose of the second matrix. يبقى as if you're distributing. Yeah. طيب. And now, but this one is a multiplication of AB. We said what we flip. We should, صح? So it is B transpose في A transpose plus, what about this one? It is A transpose في B transpose. Type, am I done? Definitely no. Where? Why? We want to reach here. AB plus BA. But how can I reach there? He told me from the beginning that A is symmetric. What's the meaning of symmetric? That this one, A, بتساوي transpose حقة, and B is equal to the B transpose, correct? Now we use the property that he gave us. طيب, يبقى ال B transpose I can write it B. Well, A transpose I can write it A because A transpose also equal to the A plus A B. طيب, I compare. Did I reach? Not yet. I need what? I need AB to be in the beginning. But what we said that A plus B is the same as B plus A. Yes, يبقى this, I can take this one, put it here, and the other two, this one, I put it there. So this is equal to AB plus BA. I switched صح? This matrix and this matrix. So am I done? Yes. يبقى now what? That is, if we have two symmetric matrices, from them I can get a new symmetric one by what? Multiplying AB, and from the other side BA. على فكرة هل AB بتساوي BA? No. We said that multiplication of matrices is not commute. في بعض الحالات ممكن يكون commute. This one equal to this one, but it's not always. So AB is not equal to BA. Clear? طيب. يبقى we prove that this is also is شنو? The new one is a symmetric matrix. So we got the transpose of this matrix and we found that it is equal to this. Clear? Now we will define a new kind of matrices, which is the skew symmetric matrix. Skew symmetric, not only symmetric, but skew symmetric. What is the skew symmetric matrix? The skew symmetric matrix is the matrix when you find its transpose. طبعا it's not equal to A. لو كان equal to A هنقول it is symmetric. But you will find that it is equal to minus the matrix A. That is what? That is every Aij should equal to the minus of Aj. Let's take the matrix C. Find the transpose of this matrix. How we find the transpose? How we need the transpose of it. How we find the transpose? By changing the row into column. صح؟ اللي هتبقى 0 minus 1 minus 3 and 4 and then etc. 1 0 5 minus 6 and etc. Correct? So you're here. Now compare between the two matrices, this matrix and this matrix as well. When you compare between the two matrices, you will find that what? Here was 0, then here was 0. Here is 1, but here is minus 1. 3, and this is minus 3. So what? this matrix هل هي equal to this one? No. It is equal to the minus sign. يعني لو ضربت دي في minus 1, so you are multiplying each element by minus 1. هيبقى minus 1 في 0 اللي هو ب 0. minus 1 في minus 1 1. minus 1 في minus 3 3 وهكذا صح؟ If this happened, we say that matrix C is what? It is skew symmetric. يبقى skew symmetric, that is the transpose of the matrix is equal to minus the matrix. طيب يبقى AIJ بتساوي شنو؟ minus AJI. Okay, or in another way, how can I know it? Sorry, easily. Just again, take the diagonal of the matrix because you want to examine, you know, a reflection of the element type. So this is the diagonal. So when here it is minus 1, here it is minus this value, correct? Which is 1. A reflection حق minus 3 هي بالminus sign, so this one should be minus this one, so it's going to be plus 3. When here positive times minus, so this is minus 5 and etc. 4 here minus 4. So AIJ is equal to minus AJI. Okay, if this happened, then the matrix is what? It is skew symmetric. So what about the diagonal? Diagonals should be في حالة skew symmetric. Should all the elements should be zeros. ليه؟ لأنه عندي ال AIJ should equal to minus ال AJI. يعني معناها ال A22 should equal to minus ال A22. But this and this, they are the same element. So كيف أنه العدد يساوي ناقصه؟ ما في حال إلا يكون العدد is equal to 0. This implies that A22 is equal to 0 and etc. for all the elements that are in the diagonal. Clear what is a skew symmetric matrix? Any question for that? طيب. Now, how we can get starting from a matrix A? Can I easily get a skew symmetric matrix? Yes. Just find the transpose of this matrix and then subtract A minus A transpose. You will find that the new one, it is what? It is skew symmetric. If you want to do as an example, let's go back here مثلا. طيب. This is a matrix, okay? And this is a transpose. Now subtract them. If I start from any matrix, here matrix A, and then minus a transpose حقها, what you will get? What is the value of the new matrix? What is the new matrix? So 3 minus 3 is 0. 4 minus minus 2, that is 6. And then minus 2 plus 4, sorry, I'm subtracting, صح? Minus 2 minus 4, so it is minus 6. And then 5 minus 5, it is 0. So yeah, 0 0 and this minus that, correct? يبقى here we saw it by an example. على فكرة, to prove, you cannot prove by examples. You have to prove in a general case that this should work ever, okay? So, or otherwise you prove it like what we are going to do. Okay, now I have this A minus A transpose. We want to prove that this matrix, it is what? It is skew symmetric. So I have to find the transpose حقها. المفروض يجيني الانسر شنو؟ what I'm expecting. What I want to test انه يكون بيساوي minus الماتريكس. But what is the matrix? This is the matrix. So minus and here A minus A transpose. So this is what we want to prove. How we will prove it? So I'll start from here. Okay. Now the transpose. Okay. Actually الماينس ساين هي زي الاديشن، يعني احنا كنا بنقول A plus we have been we said before that this is equal to A transpose plus B transpose, correct? What about if there is minus sign? It is as if we have A plus minus B, correct? And then a transpose. So again, it's the same. Okay? So this is also applicable لما يكون عندنا شنو minus sign here. It's okay. طيب. A minus, okay, so A minus A transpose, I'm going to do. So this is equal to what? This is equal to A transpose minus A transpose. So what is that? This is equal to A transpose minus, what is the transpose of the transpose? It is A. So now I check, did I reach? No, we have to start from the A. Okay, so what I do, take a minus as a common factor. Okay, so this is equal to minus times what? Minus A transpose phi plus A, correct? When you distribute الماينس هتلقى روحك هنا صح؟ اللي هي هتكون minus A transpose, which is A transpose minus A. Okay, so this is equal to what? I can flip this two. Okay, so this is equal to minus A اللي هي A and then minus A transpose, correct? Take each one with its sign. Okay, so this is equal to that. يبقى yes. A minus A transpose, this matrix, when I get a transpose of it, I am getting minus the matrix. So it is skew symmetric. Clear for all? Any question for now? طيب اوكي. هل المultiplication بديني skew symmetric? No. طيب now also we start from A and B. Both are شنو skew symmetric matrices. Okay. Then if we found AB يعني we are starting ما from any A or any B. No. A كانت skew symmetric and as well B is skew symmetric. So A في B plus B في A, he said this you will find it is skew symmetric. It should be symmetric only. So this is another way to find a symmetric matrix. Okay, we take a skew symmetric A and another skew symmetric B and then multiply them A, B, and also find BA and then add this one. It is going to be a symmetric matrix. Let's examine that. How we examine it? How we prove actually this? We find the transpose of this matrix. And we check what is the resultant matrix. So the transpose of this one is equal to AB, the whole transpose, plus BA, the whole transpose, correct? Type. And what is the transpose? And هنا multiplication. This is equal, don't forget to flip. B transpose, phi A transpose, correct? Plus, and here it is equal to A transpose, phi B transpose. Did I reach? Not yet. طيب, what property I had? From the beginning, he told me that A and B both are skew symmetric. So what's the meaning of this? That means ال A transpose is equal to minus A وال B transpose is equal to minus B, correct? يبقى I can use them here. So the B transpose is equal to what? هتساوي minus B. وال A transpose is equal to minus A. وال A transpose هنا plus. This is I multiplied them. Then plus. A transpose is minus A. Well, B transpose is minus B. So minus B. And now minus phi minus is plus. So this is B phi A plus A phi B. So I go and check. Did I reach somewhere? No. What I do? This is a matrix added to another matrix. I can. A matrix is addition is commute, so I can write it like A phi B plus B phi A, correct? I take this one there, and this one here. يبقى what I reach? The transpose of this is the same as is equal to. So I started from a transpose of the matrix and I'm getting the same matrix again. So that means it is symmetric. Okay? يبقى لما ناخد A و B skew symmetric and then I multiply AB or I multiply BA and I add them, I reach at the end to what? To a skew symmetric matrix? No, to a symmetric matrix as well. Clear? Okay, now we want to define what we call it the inverse of the matrix. What is the inverse of the matrix? Let me remind you first by the numbers. If in multiplication, what is the inverse of 2? What is the inverse of 2? Under multiplication. لازم أوري العملية. What is the inverse of 2 under multiplication? بالنسبة للضرب. الانفيرس بتاع 2. It is the number half. Why? Because when I multiply it, it gives me 1. So we say that half is the inverse of the number 2. And as well, the inverse of half is 2. Why? Because when I multiply times 2, it will give me 1. But what is this one? 1 is the identity. صح? What do we mean by the identity? That is 1 when you multiply times any real number minus 3, it will give you the number itself. Okay? So the inverse is that of a number is the number under multiplication is the number that when I multiplied times my number, it should give me the identity. Clear? Type here in matrices. If we have a matrix A, what is the inverse of this matrix A? It is the matrix, another matrix B. So when I multiply my matrix by this matrix, it will give me the identity, which is the matrix of the identity. IN type. And here as well, when we are talking about the inverse of matrices, we will find only the inverse for what? For a square matrix. What is the square matrix? Here, a matrix that a number of rows بتساوي number of columns. Okay, so for any matrix, square matrix, if we want an inverse حقها, we need to find the matrix B such that when I multiply A في B تديني identity. And as well, when I multiply it from the left hand side, so also B في A, I should again find the identity. Clear? Okay, and from now on, instead of writing an inverse by another name, مثلا B, we say that the inverse of A is what is A inverse. So this is just representing the inverse of the matrix. Okay? And so A inverse في A should give me the identity, and as well A في A inverse should give me the identity. Clear? طيب هل always the inverse exists? No. Some of the matrices has inverse, but other they don't have. If the matrix has an inverse, if inverse exists, then we say that this matrix is mala non-singular. Non-singular. So the matrix that has an inverse, we say that it is what? It is a non-singular matrix. But if inverse does not exist, we say that this matrix is, it is singular matrix. Clear؟ يبقى ما عندهم inverse بنقول الماتريكس شنو؟ بنقول A مالها is singular. لأنه شنو؟ لأنه inverse does not exist. Clear? Okay. يبقى if we want to find the inverse of A, then that means we need to find the matrix that when I multiply times my matrix, it will give me the identity. And if inverse exists, then the matrix is non-singular. If it does not exist, that means no such matrix, then we say that it is singular. Type now, moreover, if we started from a matrix A, and for this matrix we find that inverse exists, يعني exists what? A inverse, such that معناه A ماله it is non-singular matrix. Type if A is non-singular, it has an inverse, and this is its inverse. As well, طبعا this is now a matrix. If this is non-singular, then this is as well is non-singular. يعني معناه دي الجديدة دي برضو عندها inverse. Okay, so A inverse, an inverse of A has an inverse. And what is the inverse of this? You will find that the inverse of this matrix actually will return back to your original matrix A. Clear? So this is the first rule. Moreover, A has inverse, A inverse. If this happens, then you are sure that the matrix, the transpose of A, as well has an inverse. And what is the inverse of this one? It is the same as the inverse of A, and then after that find the transpose. So this is the second row. The transpose of A, the inverse of the transpose of A, it's the same as the transpose of the inverse. Okay, clear? طيب. Moreover, if عندي A has an inverse, also A to the power n will have an inverse. What is that inverse? What is the inverse of this? You will find it is the same as the inverse of A, just after that to the power n, multiplied times itself n time. Okay? Moreover, now, if we have both A and B, both of them, they have an inverse. يعني دي عندها A inverse, and this is, we can find the inverse of them. If this is the case, both they are non-singular, then as well the matrix A phi B will be non-singular. And in this case, the inverse of this matrix, الvalue حقته, it's the same as the multiplication of the inverse of B في الانverse of A. Don't forget في flipping here. يبقى these are rules. Okay, the inverse of the matrix is the matrix itself. The inverse of the transpose of the matrix is the same as the transpose of the inverse. The inverse of A to the power n, it is the same as the inverse of A and then find to the power n. And of AB, الانverse, this is في condition لازم يكون A is invertible and B is invertible. If this is the case أو have an inverse أو بمعنى تاني non-singular, then the A في B الانverse is equal to الانverse of B multiplied times. Can I flip؟ ممكن أقول بيساوي A inverse؟ No. B inverse في A inverse. Okay? طيب. Now, we want to know how we can find the inverse of a matrix. How we can find the inverse of the matrix? We can find the inverse of the matrix, our process, what you do. If we want to find the inverse of A, first put here the matrix A. Write the elements. Put it as, as a matrix. Then put a line. And here, طبعا احنا قلنا A, it is what? It is a square matrix. يعني N في N. فلو كانت 3 في 3, what I'll do here, what I put the identity, and it should has the same size as this or dimension. This is M في N, then this should be M في N. If this is 3 في 3, then this should be 3 في 3. If this is 4 في 4, وهكذا. Clear? Okay. يبقى the new matrix هيكون what is the dimension حقها؟ A كانت M في N and this is M في N. يبقى I will have how many rows? Rows N. I will have N rows. الcolumns هنا في N column. But here as well there are N columns. يبقى N plus N 2N. يبقى the dimension of my new matrix is N times what? 2N. Okay, and then what we do? Yes, we can solve it. Even 3 by 3 or 4 by 4, you can solve it in another way. But here we will know for the 2 by 2 another method for solution. Okay, type. Now, what we do? We put this one and beside it that one. And then we do row operations and try to reduce this matrix to the echelon form. To the what? To the echelon form. If you could reach the echelon form to the form that this part is like the identity, يعني 1 في diagonal and 0 everywhere else, then in this case, this is going to be the inverse. Inverse of what? Of this matrix you started from. And if you could not reach, يعني هنا دي ما جاتني في الفورم بتاع I is not in this form, so this one anything else but not the inverse, and we say that this A has no inverse. It will have an inverse if what? If when we reduce it to the echelon form جاتني هنا identity. هل always echelon form it looks like that identity? No. صح. احنا before we saw it's not in here, not in this chapter, in the previous chapter. في forms ما بالضرورة يكون one في diagonal while other elements zeros. Correct? So if this happen, then yes, this matrix has an inverse, and the inverse of this matrix is what? the left hand side, the right hand side, this one, this part here. But if this doesn't happen, then this is not the inverse, and that matrix has no inverse. Clear? Let's take an example. Now this is our matrix. He said find the inverse of this matrix. How can I find the inverse of this? Just I put a line like this. And then what we do, put what the identity. The matrix here is 3 by 3. So here we put the identity, which is of size 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And then how to proceed? Try to reduce this to the echelon form. Okay. So what we do? Now this is 1, the same way as we did before. Now this is 1. Okay. So this is the leading one. اللي احنا في first row. So the first element, the 0 element is 1. Okay. طيب. المفروض the others في الcolumn بتاعي يكون شنو zeros. يعني this one should be 0 and this one should be 0. So we want to change this one and we want to change this one. So that means we want to change the second row. طيب using R1. طيب what is the answer? Give me. هيكون عندنا how I'll make this one 0? We multiply the first row times minus 2, correct? And then we add. يبقى هيكون عندنا شنو؟ minus اللي هيكون هغير R2 صح؟ So R2 minus 2R1. Okay, so what is the matrix? It's going to be the first row as it is. So 1, 0, minus 2, and then the line, and then 1, 0, 0. Okay, what about the second line? 2 minus 2, 0. 0 في minus 2 ب 0. 0 plus 1, it is 1. And then minus 2 في minus 2, so 4. 4 plus 3, then it is 7, correct? And then we continue. Okay. 1 في minus 2 ب minus 2 plus 0, it is minus 2. And then 0 of minus 2, طبعا 0 plus 1, 1. And 0 of minus 2 is 0 plus 0, it is 0. Clear? Type. And then also we need to make this one 0. So I multiply now this times minus 4 and add. 4 minus 4, again it's 0. 2, 0 في minus 4, 0 plus 2, 2. Minus 2 في minus 4 is 8. 8 plus 5 is 13. Correct? Minus 4 في 1 ب minus 4. وهكذا. Okay? Minus 4 في 0, 0 plus 0, 0. Minus 4 في 0, 0 plus 1, 1. So now this is the leading one and all the other entries here are 0. Now we come to the second row. The first non-zero element, this is 0. The first, it is already 1. Okay, alhamdulillah, this is 1. What remains to make this one 0? And you keep on doing the steps till you reach to the echelon form of this part. Let me show you. Okay, so we do the steps. Okay, we are here, correct? And now what? You keep on. So here, this is 1 and then 0 and then 0, correct? Type. Now what we need? We need to make this 1. We need the leading one for this one. So here we multiply مثلا by minus 1. Okay, so now this is 1. What we need to make this 1 and to make that 0 after. خلاص, you can need this 0 and this 0 and etc. So where I reached this one. Isn't it the identity? Yes, it is the identity. So this is what? This is I, the identity, I3. Ibga, this one, I managed to reduce it to the echelon form, and not any echelon form, actually to the identity. When it is reduced to the echelon form, this echelon form like the identity. يبقى A has an inverse. Yes, it has an inverse. What is the inverse of A? So just this part is the inverse of A. So this is A inverse. Type. If I want to make sure that this is the inverse, what I do? Just multiply your A times A inverse. It should give me what? It should give me the identity. Because we said that the inverse of the matrix, when I multiply it times the matrix, this is the definition. It should give me the identity. Okay. If this happens, or also as well, المفروض يكون عندنا A inverse في A should equal to the identity. Clear? So if you did it, you will find that the result is the identity. Okay. So make sure that you're doing a correct step when you're reducing to the echelon form. طيب. For the 2 by 2 matrices, you can use the same method, yes. حتى لو الماتريكس كانت 2 by 2. 2 by 2. Okay. So هاخد identity 2 by 2 and I continue. طيب. هل في another method? Yes, it is more simpler and more easy in the case of 2 by 2 matrices. طيب, what is that? How we can find the inverse of this kind of matrix? Okay, what's the rule? Type the rule is that what? Flip these two. So put each one in the place of the second. So هيكون هنا D and then this is A. Leave the B and C in their place, but multiply by a minus sign. So minus B and minus C. Is it only? No, don't forget. Then this you multiply times a number. Which number? 1 over what? Multiply A في D. So AD and subtract from it B في C minus B في C. So هنا over AD minus BC. So you'll get a number and then you multiply times the matrix. طبعا معناها times each element in the matrix. You got how we can find the inverse of a matrix if it is 2 by 2. So this is another way of finding the inverse for a 2 by 2 matrix. But as well, I can solve it using the same procedure as before. Okay? Like for instance, let's take an example. What if this is A? Let's find the inverse. It is 2 by 2. Can I use this method? This method? Yes. So what we do first? We flip. صح? A 2 and 4. So 4 and 2. And then this one and this one as they are, but with a minus sign, minus 6. And don't forget what times what? 1 over what? 2 في 4 by 8. 8 minus 1 في 6 by 6. So 8 minus 6. So that is equal to 1 over 2 multiplied by 4 minus 1 minus 6 and then 2. If you want to leave it like that, you can. If you want, especially in quizzes, because you may be looking after a certain value. So you multiply 4 في half. So this is 2 and this is minus 1 over 2 and then this is minus 6 over 2, which is minus 3 and then 2 over 2, that is 1. So this is the matrix. Type. If I want to make sure that this is the inverse of the matrix, what I do? Take it and multiply it times this. You should get what? You should get the identity. And here he did it for you. Clear? And this is done certainly if you have time. After finishing the exam, you can check your solution like that. طيب. The most important thing, don't forget this part. اللي هو 1 over AD minus BC. Now, what if this multiplication equal to 0? Can we divide over 0? No. So this will be undefined. In this case, there will be no inverse. From the beginning, for me, it's better I evaluate A في D minus B في C. If I got a 0, then immediately I will write that there is no inverse for this matrix. Clear? Okay? Okay. If get 2 by 2 matrix also, repeat the solution of this one, you mean? Rowa? Type. How we get the inverse? What we said, what's the rule for a 2 by 2? Just flip the place of the 4 و 2. اللي هي بقت هنا كانت 2 بقت 4 و 2 down. It is here. Then this one was minus sign and this was minus sign. So minus 6 here and here minus 1. Did I finish? No, not yet. What? Times 1 على AD minus BC. So this time that, this is 8 minus this time that. It get 8 minus 6, which is 2. So half times the matrix. And now you can multiply like that or leave it like this. If you multiply, we knew that. How we multiply a matrix times a constant? That is each term here in matrix, I should multiply times half. So I got this one. Clear? طيب, and I said that if a number هنا مثلا جاني 6 minus 6, so 0, 1 over 0 is not defined. What we say? We say that A has no inverse. يبقى في حالة this one, a result here is 0. Before you proceed and find this part, immediately say that inverse does not exist. Or this matrix has no inverse. Another word, remember it, it is not invertible. The one that has inverse, we say that it is invertible. If it has no inverse, so it is not invertible, non-invertible. Clear? Right. Now, we want to use this property in a when we are solving. We knew that in the first chapter, our aim is to solve the system of linear equations AX بتساوي B. This is in case that the system is not homogeneous or is equal to the 0 in the case of the homogeneous system. So, and we knew how to solve. We found the augmented matrix, correct? And then reduce either the triangular form or to the echelon form and then solve. طبعا على فكرة, if the matrix here, this part, هنا this is B, if this part is not square, so I cannot reduce it to the triangular form, صح؟ ما حيبقى triangular لأنه ما حيكون عندي diagonal like this. يعني إلا لو كانت 3 by 3 ولا 2 by 2 ولا 4 by 4. Okay, anyway, we knew how to solve this system before. Reducing to the echelon form and etc. Type. Is there another way for solving this system using matrices? Yes. If I knew that this matrix is invertible, that means it has an inverse. إذن هيكون شنو عندي A في A inverse is equal to the identity. Correct? Okay. So easily I can use this property to do what? Type. If I multiply, and احنا all we said that what we do في left hand side لو كان عندي equation في equality, what we do in this hand, we should do it in this hand as well. Correct? طيب. يبقى I will multiply this from where side? From the left. لأنه ال A قاعدة هنا. Okay, so I will multiply from here by A inverse from this side. يبقى I should multiply from this side as well by A inverse. يبقى هيكون عندنا شنو? I will have that A inverse في A في X, it should equal to A inverse في B. Yes, equality will hold as well. طيب, but what is this? This is the identity. طيب, identity times X is equal 2A inverse في B. إذن حيكون عندي شنو؟ Any vector or matrix times the identity. Okay. إحنا we had it as a rule before. صح في الماتريسيز. This will give me the same x. So x is equal to A inverse في B. إحنا our aim when we solve the system of linear equation to find the vector x اللي هو فيه ال x1 المتغيرات y1 و z1, correct? So that means I can find it like that. Just multiply this, the inverse of this matrix, times your vector b, and immediately you will get a solution. Clear? يبقى this is when you can use this method. If this one has an inverse, لازم يكون A inverse exist. And matrix has an inverse, it is non-singular. Then you can solve your system by this method. And it's easier and the steps can be less. But otherwise you cannot if it has no inverse. How you will solve like that? No way. طيب. Moreover, now what do you think? لو A has an inverse, عندها inverse, okay, so that is A inverse exist. طيب, that means when we reduce this one to the echelon form, احنا بنجيب الانفيرس كيف؟ متذكرين؟ كنا بنخد ال A والidentity, correct? Like this. Yeah. And then after that we try to reduce this في echelon form. If I manage to do, then this part is the identity. And this part is what? Is the inverse. طيب, if this exists, معناها شنو؟ معناها this part اللي هي ال A, when I reduce it to the echelon form, it's going to be in this form. So it's going مثلا لو كانت 3 by 3, it's going to be like 1 0 0 0 1 0 and then 0 0 1. And here in this part, I will have, because I have, please mute your mic. And in this part here, what? And when I am solving before, لما كان AX بتساوي B, لما عايز أعمل ال augmented matrix, what we do هنا A, and then a line, and then here the B, correct? Like that. Yes? طيب. طيب. So we do like that, correct? And then we reduce to the echelon form. يعني أنا ما كنت بخدها هنا I, الايدنتيتي، صح؟ When we are solving كنت بخدها ال B. But again, the same steps I'm taking here, I'm taking here. صح؟ همي كان ال A أوصلها لل reduce echelon form. طيب هنا همي ال A also to reduce it to the echelon form. This was my task. يبقى if here the A reduced to the echelon to the identity, يبقى here as well it will be reduced to the identity. يبقى what I'll get something like that, and here some numbers. For instance, 2 minus 5 and مثلا 3. Let's say, for instance, as an example, okay? طيب, يبقى what I'll have, what kind of solution I will have in this case? Tell me, what kind of solution you will have? احنا عندنا solutions either unique solution, infinitely many number of solutions, or no solution. So tell me, what type of solutions? Which one of the three you will have? يا واحد من الثلاثة اللي اتكلمنا عنهم قبل شوية. No solution? Infinitely many? Unique? What? How can I know? Unique, why? Because عندي كم leading one. The first row, the leading one حقه. Second row, the leading one. Third row, yeah, this is, so I have how many leading ones? 3. How many unknowns? 1, 2, 3. يبقى what I will have unique solution. يبقى ممكن نحطها now as a rule. If I want to solve the system AX بتساوي B, and I knew that such that an inverse of A exists, يبقى شنو؟ يبقى immediately I will know that this system has what? Unique solution. قبل ما أحل خلاص عرفت A inverse exist، يبقى immediately because the system will reach something like that، يبقى the linear system will have a unique solution if the inverse exists. Clear? And what is that unique solution? It is just multiply here by the inverse from the left hand side and as well from the left hand side here. So this is going to be the identity. So from here you will get that your x has a value of A inverse of B. So just multiply this by this and you're going to find some values like that. هتلقاه vector like this. 3 elements 4 على حسب طبعا الماتريكس حقتك. Okay? So يبقى this is the vector x. That is this is equal. هيكون هنا ال x1 ال x2 ال x3 وهكذا. يبقى what is the value of x1 x2 and وهكذا. Okay, and we'll do some examples. But the most important thing is that if عند n equation in unknown طبعا ده ما في كل الاحوال الا احنا قلنا الانفيرس ما بنقدر نجيب الا لو كانت الماتريكس is a square matrix. هل this applied ل any system؟ لا no. when if عندي n equation في unknown n unknown عشان ما تكون this matrix is what is a square matrix, so I can find the inverse of it. يبقى you can go like that من الأول. إذا كانت الانفيرس حقت ال A حقتك it is what? It is a square matrix. And what is the unique solution? It is that. Now, moreover, now what if the system is homogeneous? What if the system is homogeneous? What do we say? طيب a homogeneous system, what type of solutions a homogeneous system will have? Always any homogeneous system AX بتساوي 0, it could either have a unique solution, correct, or infinitely many solution, correct. احنا before we said could it has no solution؟ هل ممكن يكون عنده no solution this one؟ possible. I'm asking you, is it possible إنه يكون has no solution? No. Why? Because it can never happen. أنا عندي دايما الجزء بتاع البي كله zeros. How come واحد من دول يكون number؟ عشان يكون عندي زيرو مثلا 0 0 0 0 ويكون هنا عندي number مثلا 2. This cannot happen? No. Why? Because always البيز are zeros. يبقى مستحيل الهوموجينيوس system يكون عنده شنو؟ No solution. Always it has a solution. Either a unique solution or infinitely many number of solutions. طيب. Now moreover, what if the inverse of A exists? What if the inverse of A exists? What do you think? طيب الانverse exists معناها شنو؟ معناها when I reduce this part to the echelon form هيصل to this one لأنه inverse أنا قلت exist والinverse is going to be this side, correct؟ يبقى again هيكون عندي unique solution. But what is the solution in this case? البيس هنا هيكونوا شنو؟ هيكونوا zeros, correct؟ 0 0 0. يبقى here this part لأنه system is homogeneous وقال لي system is homogeneous this one, so this is going to be 0 0 0 and I have a unique solution. So what is the unique solution? X بتساوي 0, so لأنه ده corresponding للX, this is for the Y and this is the Z. So X بتساوي 0, Y بتساوي 0 and as well Z بتساوي 0. So in this case I will get, يبقى لو عرفت إنه الانverse exists for this A, immediately I will know that I'll get a unique solution. Not that only, but also what is that solution? It is the zero solution. And we call it the trivial solution. بنسميه شنو في الحالة دي؟ بنسميه zero solution، بنسميه trivial solution. اللي هو x بتساوي 0. يبقى trivial solution هو السوليوشن الصفري، الحل الصفري، الزيرو solution. اوكي طيب now what if A has no inverse؟ طيب A has no inverse يبقى وأنا I'm reducing to the echelon form. Can I reach this form؟ No, I cannot reach this form. لأنه الانفيرس does not exist. صح؟ يبقى what is the reduced echelon form؟ Something different. Correct؟ يعني ممكن مثلا يكون 1 0 0 0 1 0 0 0 0. طبعا here I have 0 0 0. هل this is an identity؟ No, it's not the identity لأنه لو ال identity this one should be 1. This element. يبقى I will have how many solution? Infinitely many solution. Which column has no leading one? This one. So I said let Z بتساوي T and proceed your solution. Clear? يبقى knowing that A has inverse or not will let me know that it has unique solution ولا infinitely many number of solutions. اوكي ولا infinitely ولا حتى no solution في حالة AX بتساوي B. طبعا المهم you will know either no solution either sorry unique solution أو واحد من اثنين infinitely many أو no. طيب لأنه لو وصلت للايدنتيتي يبقى خلاص unique solution. Okay? Is it clear what I said? Please go through this part later again. Now let's see how can we solve. على فكرة this part الحاجات زي كده مهمة في حالة الكويز في true وال false. You have to understand the things well. طيب. Now this is a matrix A and this is the matrix B and then he said solve the linear system AX بتساوي B. This is the A and this is the B. If I want to solve in our previous using our previous method, what we do? We do the A and here the B, find the augmented matrix and then solve, correct? As we did before in the previous chapter. طيب now we want to solve in another way. طيب now this matrix. If in part A of the question كان قال لي find A inverse and I found it. I found that the inverse exists. Do I have to go and use this? No. To gain time. Already I have this one. What I do? Since the inverse exists, I do and the AX بتساوي B. We multiply from the left hand side by A inverse and as well here from the left hand side because here I multiply from left, then here from left. Then what is this one? The identity في X is X. X بتساوي A inverse في B. What remains to do? Just from part A, you got this one. Put it here and multiply it by the B. Here, the A inverse. Just it's a matter of multiplication then after. طيب, actually this is this, which we got its inverse. Where is the inverse? It is this one. Okay, what now remains? Take this one and multiply it times the B. So take this one and multiply it times the B. Okay, as if you had it in part A. And let's say that PowerPoint, it is the part A of the question. So now part B, he wants me to solve the system. I can proceed like that, but this will take long time and I am in need of every minute. So what remains? Just multiply here this one and make sure A inverse it is in the left. So just multiply it times B. So this is the inverse times B, and we know how to multiply. We multiply a row times the column. It will give me the first answer. And then لأنه ما في تاني column تاني. And then this one times this one, it will give me the answer, and then it will give me the answer. يبقى what is the value of X is 1. B minus 1, C is 2. Clear? Clear? طيب. let A equal 1 to 1 this matrix. Is A non-singular matrix? Explain. What is non-singular? Tell me. What is non-singular? What is non-singular? When we say that the matrix is non-singular, if it has inverse. صح؟ لو ما عندها inverse exist أو exist A inverse, this implies the matrix is what? It is non-singular. Okay. يبقى we want to prove that it is non-singular. What I do? I come and look here. Okay? We need the inverse. It will help me to solve this part. Then I go and find the inverse. طب how we find the inverse? I just put a line like that and then put 1 0 0 0 1 0 0 0 1 and reduce to the echelon form. If I manage to do خلاص يبقى the inverse exists يبقى it is not singular. Okay, so we proceed. Let's see here. So we started with the matrix. Okay, and now we try to reduce to the echelon form. So this is the leading one. Make these zeros. We made them zeros. Okay, so I reach here. Now we come to the second row. The first non-zero entry. We have to make it 1. Already it is 1. Remains to make what? The two numbers with it in the same column to make them zeros. So this one to make it 0 and this one to make it 0. Using what? Using this row, الهول فيه leading one. And I have to do for all. Don't forget that part. Okay, so I made these two zeros. Now I reach here. طيب, can we reduce لسه more? لما نجي للثird row, all the entries are zeros. يبقى I'm done. I cannot خلاص. This is in the echelon form. طيب, now this one is in the echelon form. صح؟ هل هي singular ولا non singular؟ Tell me. هل هي في الفورم بتاع الاي ان؟ في الفورم بتاع الايدنتيتي؟ I3؟ No. الاي 3 هو كلهم ال1 في الدايجونال 0 1 0 0 0 1. So it is not there. Correct? يبقى it is شنو؟ It is not in this form. يبقى طوالي معناها inverse does not exist. يبقى does not exist شنو؟ ال A inverse. ما موجود. ما عندها. يبقى it is what? It is singular. طيب, it is singular. Now we come here back. He asked me to solve the linear system AX بتساوي 0. هل أقول له ما في solution عشان ما بقدر أضرب A inverse في AX بتساوي 0 then X هل أقول no. No. It could be, it could has a solution. How I solve? طيب أنا ما قدرت أجيب ال A inverse. How I solve? You go and use our usual method. Reduce اللي هو ال A وجنبها ال B. ال A اللي هي this one. We find the augmented matrix like we did before. Okay. خلاص ما بقدر أحل بال A inverse. So I go and try to solve using another method like that. Reduce to the echelon form and then find the solution. طيب, do I have to do all the steps again and reduce to the echelon form? هل محتاجة أمشي step by step? No. Why? Because already I tried to reduce this in the echelon form, and the most important thing, this is because this will remain 0. ده أصلا ما حيتغير once أنهم 0. لو كانوا أرقام, no, I cannot use this one here. So here what? As if بدل ما هنا ده يكون كده, كان just عندي one row فيه 0 0 0. Okay, and then here صح 0 0 and it will remain the same لأنهم ديل أصفار. But لو كانوا number 1 2 3, can I use the same steps here? No. طيب, at the end what I will reach to? I will reach to this matrix لأنه this is the echelon form of the A. صح؟ طيب. So what I do, I put this the A and I know that the row لأنه هي كانت homogeneous system الرو حيكون أصفار. اللي هو هنا ده sorry في reduced echelon form. Okay? Like that. So I take this one and put it and beside it zeros. Now, do you know why he just immediately take this part? لأنه this is the reduced echelon form of our original matrix. And no need to do the steps again. ما في داعي أعمل ال steps again وأمشي. Can I do? Yes, I can do. But I am going to waste time and I am in need for every minute. بدل ما أعيد الخطوات تانية وأنا عارفة الأرقام اللي هنا ما حتتغير لأنها أصفار. Why am going for that? No need. يبقى what I do, just I take this, put it and put the zeros. بس في حالة إنه السيستم homogeneous. لو ما كان homogeneous هنا مديني B, don't do like that. You have to do the whole steps كده وهنا B لأنه الأعداد هنا حتتغير. واضح؟ From step to step. Okay, so now what is the solution? عندي كم leading one? I have this is first leading one. Yes, في second row this is the leading one. Here we don't have a leading one. يبقى what we have, the number of leading one is less than the number of unknowns. عندي كمان unknown 3. Okay, so how many solution? Infinitely many number of solutions. طيب هل ممكن يكون no solution؟ لا لأنه هنا 0 0 0 but here 0. Okay, لو كان هنا رقم, if it was a number here, then we say no solution. But now here there is infinitely many solution. What we do, we let z بتساوي t and then solve. And I know you can do it. صح؟ اللي هو حيكون عندنا في الأول x plus 3t is equal to 0. That is x بتساوي minus 3t. Correct? And then after that, from the second row, y minus t بتساوي 0. يبقى y بتساوي t. صح؟ y حتساوي t and etc. And then after that, you put it like that such that t belong to r. لو قال عايز exact solution, عايز حل واحد معين, give t any value. مثلا 0. تبقى 0 0 0 is one of the solutions. Another, he need another solution. Take t by 1. يبقى حيكون عندي minus 3 and then 1 1. So this is another exact solution. and هكذا. So I can generate infinitely many number of them. Clear? Okay. طيب. Let A be this matrix and be this matrix. Find A square inverse. So I will start read the question and to know which method to take. Find the matrix X such that A transpose في X بتساوي B. It's clear I need the A inverse first because I can use it here. Okay, and as well I can use it here because I have some rules. Okay, so the thing first that comes to my mind that I need the A inverse. Okay, if it exists, it can help me a lot if it exists. So I try to find the A inverse. Okay, what is the A inverse? You do the same. Put this some line and then 1 0 0 0 1 0 0 0 1 and try to reduce to the echelon form. طيب if I get it, then what? هنا I need A square. الانفيرس of A square يعني A في A حتى نجيب الانفيرس. But we had a rule before, which is easier. What's that rule? It say that the inverse of A to the power n is the same as finding first the inverse and then multiply this matrix times itself n time. So already I got this A inverse. When I did this, I got A inverse. What remains? Here al power 2, so n2 يعني هنا A square to this is square. So what remains? Remains to find, to multiply it times itself. So it's the same as A inverse square. So it's the same as A inverse times A inverse. Clear? طيب. Now, find the matrix X such that A transpose في X بتساوي B. That is, I need a vector X of the variables. So always to find something, you have to put it in one hand alone, correct? So that is, you need X بتساوي what? Type. So I want to get rid of this. Type. To get rid of that, what we do? We multiply from the left-hand side by the inverse of A transpose, correct? So, and what I did in the left-hand side, I'd have to do it for right-hand side. يبقى حيكون عندي شنو؟ A transpose الانverse حقها then times A transpose, correct? Sorry, A transpose times A transpose times X. This is should equal, since I multiplied from the left, I should multiply this one as the left from the left as well. A transpose الانverse حقها في B. Type. Why? Because the inverse of this matrix times this matrix, it is the identity. So this one and this one هتديني الايدنتيتي في x بتديني x. So x بتساوي ال A transpose الانverse بتاع ال A transpose في B. طيب, but from the first step I found it A inverse. Can I use it? Yes. Why? Because I had a rule. Which rule is that? That the inverse of A transpose, it is the same as the inverse, find the inverse, and then for this inverse, find the transpose. But already I found this one. Remains to find the transpose. Here I'll take longer, but here already in step 1 or في part A, I found the inverse of the matrix. So what remains? To find the transpose of this matrix. So what you do? This one, we say that it is equal to an A inverse transpose بدل دي بعدين multiply it later by B. Already I have this. Remains to find the transpose. So يبقى ال solution X هيتساوي شنو؟ A inverse transpose حقها في B. Clear? Let me show you. طيب. We got the inverse. Go and check it. You have to do the steps. Try to find the steps, the inverse of this. Make sure that you know how to find the inverse. So this is the inverse. Okay. Then now what we need? We need A square inverse. I said what you do. Find this inverse and then square it. This times itself. It's easier. بدل ما أجي أربع دي وحتة تانية it will take a long time. لأنه I have property here. Okay, so just multiply this time that, and I'm getting this one. Now we want to solve that. I told you to find what this times B, because we already get the inverse here. So we use this one. لأنه in the property that this one is equal to this one. Yes. So times B. So this one اللي هي كانت عندنا الانفيرس هجيب الترانسبوز حقها, change the row into column, correct? So 0 1 0 0 1 0 1 minus 1 وهكذا. And then we just multiply times the B, and I got the solution. يبقى الماتريكس X is which matrix? It is the matrix this one. You got it? هي عندها 1 minus 4 الرو الأول والرو وهكذا. طيب تفضل ال last part. Find the matrix Y such that Y في A بتساوي B transpose. Find this matrix Y such that Y في A بتساوي B transpose. Okay, how can I find it? What we need? We need the matrix Y بتساوي كده في كده. What I want to get rid, I want the Y in one hand. That is, I want to get rid from this one. And I knew that the inverse ماله exist. So I use the property. I multiply by A inverse, but from where? يا جماعة لو كان عندي A inverse في Y في A, can I multiply this في this first? No, because we said A في B is not necessarily equal to B في A. So you cannot, no way to put this beside that. إلا لو كانت من نفس الجهة جنبها. Then you can multiply. Okay? So make sure from which hand you will multiply. طيب يبقى Y في A. I want to get rid of the A. يبقى هضرب ال A inverse from this side. إذا Y في A في A inverse is equal to, I multiply it from the right hand side, I have to multiply it here from the right hand side. B transpose في A inverse. And then this times this بالidentity. يبقى هنا بقى عندي Y في الidentity which is Y بتساوي B transpose في ال A inverse. Okay? يبقى what remains? عايزة B transpose, but this is the B. يبقى هجيب transpose of the B which is equal to 2 3 1 0 0 2. So this is my B transpose. Multiplied times what? Multiplies times this inverse of an A. So times the A inverse. الدايمنشن حق ال A inverse هيساوي شنو؟ هيساوي 3 by 3. Okay. And what about this dimension? It is 2 times 3. Can I multiply? Yes, because this is 3 and this is 3. So what is the resultant? الماتريكس الحجيني dimension حقها 2 في 3. 2 في 3. طيب let me show you. يبقى this is a B transpose and then times A inverse and then you do the calculation. You will get this one. طيب, is it clear? Any question in this chapter of matrices, or it is clear? Do you have any question? Type, okay. يبقى كده we finish this chapter and we're going to start the new chapter.